Hey guys, today's lesson is over angle bisector proportionality theorem. I'm going to go ahead and write down the theorem for you to copy down, and then I'll show you guys how to apply that theorem in different situations. Let's get started. An angle bisector of a triangle divides the interior angles opposite side into two segments that are proportional. And they're proportional to the other two sides of the triangle. One key word inside of this that I want to point out is that there has to be an angle bisector present. If there's not an angle bisector present, then this theorem does not apply. So you don't want it to apply it to situations where there is not an angle bisector present. I'm going to wait just about 10 more seconds for people to wrap this up, and I'll show you what I mean in the example below. Okay, so if we look at this first problem, the given piece of information is the most important piece. If we didn't have this given piece of information, we could not apply the theorem. So we have angle RVS is congruent to angle SVT. Okay, what that means is that VS is an angle bisector. Because it's cutting that angle into two congruent pieces. So this angle bisector, VS, okay, is splitting this side proportional to the two other sides of the triangle. So I'm going to talk about a few different ways we could set up a proportion. I'm going to set up the first fraction, and you make a guess as to what the second fraction has to be. All right, here's one potential option. I could do 8 over 4. If I did 8 over 4, what do you think would have to be the order of the other side? Take a guess before I share out. 10 over x. All right, let's try another potential option. What if I decided to do 8 over 10? Take a guess before I share out. If I did 8 over 10, what do you think has to be the order of the other two sides? 4 over x. All right, let's try one more example, and then we'll solve one of these. All right, what if I decided to do x over 10? That would have to be 4 over 8. Notice that in all of these cases, the x is going to the 8, and the 4 is going to the 10. So all of these we would be solving for the exact same value. That would give us 8x is equal to 40. Therefore, x is equal to 5 in this case. All right, let's try it in a new scenario. All right, we got to read the given information. Given that segment BC bisects that angle. All right, well, if it bisects this angle ABD, it's cutting the angle into two congruent pieces, and it's splitting the opposite side proportionally. Let's fill in this given information. AB is 8, DB is 6, DC is 5, and they want us to find AC. All right, I'm going to set up the first fraction, and you tell me what the other one has to be. Let's do maybe x over 5. If I did x over 5, What has to be the order of the other two? Eight over 6. Let's try one other example. If I did 5 over 6, take a guess as to what the next one would have to be. That would have to be x over 8. All right, notice in both of these cases, the 5 is going to the 8, and the 6 is going to the x. So we have 6x is equal to 40. And then we can just divide by the 6 on both sides, giving us that x is equal to 6.6 repeating. Okay, when you're ready, go ahead and flip to the back. Or if anyone has a question, feel free to pause the video and ask either Ms. Miller or Coach Price. Okay, I know that I can apply angle bisector theorem because I can tell by these arcs, okay, that this segment is bisecting that angle. Therefore, it's splitting the opposite side proportional to the two other sides of the triangle. Well, if the entire length is 16, we can do 16 minus 6.4 to see that this side is left with 9.6. All right, now that we found that missing piece, I'm going to set up the first fraction and you tell me what you think the other fraction would have to be. If I did 8 over 6.4, take a guess. Good, that would have to be x over 9.6. Let's try one more just for practice. If I decided to do 6.4 over 9.6, take a guess as to what the other side would have to be. Good, 8 over x. Notice that in both of these cases, the 8 is going to the 9.6. And the x is going to the 6.4. So both proportions are valid. So we have 6.4x is equal to, let's see, 9.6 times 8. That's 76.8. Let's divide by 6.4 on both sides. So it looks like x is equal to 12. Okay, the next theorem we're going to take a look at, the triangle proportionality theorem, is really just the side splitter theorem. That we talked about yesterday, applied to triangles specifically. So I'm going to show what this theorem looks like in a very generalized case below, where there's no number, so we're just going to talk about the sides or the segment lengths in the next example below. Okay, because these lines are parallel, it's cutting these sides proportionally, so we can do part over part is equal to part over part. So I'm going to set up the first fraction, and you tell me what the other fraction would have to be. All right, if I did segment AB, the length of segment AB over the length of segment BC. So the length of segment AB, which is this guy right here, over the length of segment BC. What do you think would have to go on the other side of this? Take a guess before I share out. Since I did AB on top, I'm going to have to do AE on top. And then ED on bottom. Let's try one other example. And then in the next question, we'll actually apply it to a problem where we can solve for something. If I were to do BC over ED. So I did BC, right, this piece over this piece. What would have to be the other side? Take a guess before I share out. All right, since I did top over bottom, I'm going to do top over bottom. So that would be AB over AE. Okay, notice in both of these cases, AB is going to ED and BC is going to AE, right? So they're both really solving for the same thing. All right, let's apply this in a problem on the next page. All right, for one of these, we can use the triangle proportionality theorem, or AKA the side splitter theorem. And for one of these, we cannot use it. So let's talk about which one we can use it for and which one we can't use it for. Let's talk about X first. Do you guys think that we could use side splitter theorem to find X? The answer is yes. You can use side splitter to find X. Okay, then let's look at Y, right? Y is not a part of a side being cut by the parallel lines. Y is a parallel line. So you cannot use side splitter to find Y. All right, let's solve both of these cases. Let's start with X. I'm going to set up the first fraction. If I were to do this part over that part, so X over 8, what would have to be on the other side? Got 6 over 4. All right, so we are going to get 4X is equal to 48. Which means X is equal to 12. Since I can't use side splitter theorem to find Y, I'm going to color code. Let's start with Y, right? I need to find Y. So Y corresponds with 18. The 6 corresponds with 10. And the 12, which we just found, corresponds with the 20. Because I know both green values and both pink values, I could really set up purple with pink, or I could set up purple with green. You have options. I'm going to go purple with green for my setup. If I were to do purple with green, maybe I pick 18 over Y. I did big purple over little purple. Well, if I did that, then I'm going to have to do big green over little green. So then we can go ahead and cross multiply to solve. So 18 times 6 is going to give us 108. And then we'll get 10Y on the other cross multiplication. And when we divide by 10, we'll get that Y is equal to 10.8. All right, looking at the next case. I can use side splitter to solve for X because those are part of sides that are actually being split by the parallel lines. So we can do part over part, but I do need to find this part right here, right? 24 minus 8 is going to leave us with 16 for that part. All right, so if I were to do 8 over 16, take a guess as to what would have to go on the other side. Okay, I did left over right, so I'm going to do left over right. Now, when you cross multiply this one, you're going to have to be very careful with your distribution. It's 8 times this entire binomial, and it's 16 times this entire binomial. So we're going to have to make sure that we distribute into the parentheses. All right, I can subtract the 16x over, so 48 minus 16 is going to leave us with 32x. I can subtract the 16 on both sides. and then I can divide by 32.